I'm going to show you something which is a rich guy promoting another rich guy's ideas about AI and physics. And it kind of caused me to crash out just a little bit.
The other thing is physics. So this is Peter Thiels' point, but minus the screens from any room, we're living in the 1970s, right? So nothing's happened in physics since 72. String theory has not got us anywhere.
Okay. Why string theory? Like, why? Honestly, I feel like bringing that up, it makes me just kind of go, nothing else you're going to say is valid to me because you don't actually understand anything about modern physics, anything about actual scientific research or what's important to us in science and important to our society if what you're using as your anchor point is string theory has given us nothing. It's an absolutely insane comment to make. Okay, so physics, I get this comment all the time. Physics has given us nothing in the last, since in the last 50 years. What have we gotten from physics in the last 50 years? Why is it the 50 years? Is it Peter Thiel? Did this all originally come from him? Is this where this like 70s thing comes from? I don't know. I don't get it. But let's talk about what physics has done since the 70s. Now, I'm not talking about big mystery theories. I'm not talking about questions like what is dark matter or, can you unify gravity with quantum mechanics? I'm not talking about string theory. I'm not talking about loop quantum gravity. I'm not talking about where's all the antimatter. These are mysterious questions on a cosmic scale that are interesting in theoretical physics. They're not necessarily interesting to everyone. The string theory thing is just like a marketing hype that like people really caught on to and got so caught up in their own brains that they thought, oh, string theory is like, what, maybe, blah. I don't know. I blame this. I blame this book. I blame Brian Greene and I blame this book. Because in this book, he talks in absolutes. Like he never says things like, oh, if string theory is the solution, then we might be able to detect supersymmetric particles using the LHC. He says, string theory is the solution and we will detect supersymmetric particles. So then when we didn't, people are like, oh my God, physics has failed. And it's like, well, no. It's a small group of theoretical physicists that are interested in string theory. Like relative to the actual broad scope of what physics is as a general topic, string theory is like barely a 0.000% of the amount of actual physicists that work on it. It's just that it got really big in the public's imagination. But anyway, let's talk about what we've done since the 70s. The whole thing of like, take away the screens. Like, what do you mean take away the screens? Our world is built on technology. What do you want outside of that? Take away the screens. What else do you want from physics? Physics is about our interaction with the world. That's what it does for us. We are able to understand classically how we interact with objects, and we're able to understand on a quantum level how we interact with objects. And then we take that understanding and we apply it to technology to advance us and bring us forward. If you take away the screens, what other kind of a world do you want to live in or do you expect to exist? Okay, so since 1972, let's just talk about one thing that's really important to us, GPS. Okay, now GPS matters because satellites experience time differently due to Einstein's theory of relativity. So one of the ways that we're able to correct for this is by having really, really advanced clocks, right? So atomic clocks have been a massive advancement in physics and development in recent decades. So without GPS, we wouldn't have aviation the way that we have it today. We wouldn't have global shipping. We wouldn't have finance timestamps. We wouldn't have emergency services the way that we currently have them. Smartphones would fail. You wouldn't be able to, you'd still be pulling out your paper map to get you anywhere, and you wouldn't have Uber driving you places or picking up your deliveries for you. Now, your phone exists because of quantum physics, and it's specifically quantum physics research that developed after the 1970s. And what actually changed is related to semiconductor physics, okay? So MOSFET scaling, quantum tunneling control, bandgap engineering, nanofabrication. These are all problems that were solved after 1972. And the impact that they have is obviously smartphones and laptops, sure, Wi-Fi, Bluetooth, AI chips, medical devices, electric cars. We're going to come back to the AI chip in a minute because it's the one that drives me crazy. Without this physics that happened post 1970s, Computer chips would be massive. They would overheat immediately. They would be slow, they would consume insane amounts of power, and they would cost thousands. So computers would be completely inaccessible to most of us. One area that people don't seem to recognize is connected to physics is medical physics. Right? Medical physics is an entire area. And basically this is taking the knowledge and the understanding that we have developed from actual physics research in terms of imaging tools and detectors, and using that to create things that allow us to advance in medicine, specifically in medical imaging. So things that we have only had since the 1970s is MRI imaging, and that requires quantum physics, superconductivity, and RF physics, that's radio frequency physics. Most of the software and hardware breakthroughs that allowed this to happen happened in the 1990s and the 2010s. CT scans. CT scans exist because of advances in detector physics. PET scans, I can't believe I have to say it, positron emission tomography, literally comes directly from particle physics, adapted for medicine, of course. So the real world effects that we have from this advancement in physics is earlier cancer detection, fewer invasive surgeries, better survival rates, and faster diagnoses. I understand that people don't get what's been going on, but this claim of nothing has been happening for 50 years is just wild. Advancements in physics in the last 50 years that allow us to have things like the internet are laser physics, fiber optic materials, low loss signal transmission, error correction in physics noise models. These are all really specific things that we needed to get us to where we are today. And without them, we wouldn't have streaming or cloud computing or modern finance or global communication. You wouldn't have Zoom. A big one that people tend to ignore because they try to, they don't care about climate crisis and stuff like that, but renewable energy exists because of modern physics. So solar panels, they rely on quantum efficiency improvements and band gap optimization. Wind turbines rely on fluid dynamics modeling and materials physics. Batteries, just the batteries that you use are based on solid state physics, electrochemistry, and nanostructured materials. This all happens, these improvements happened after the 1970s. String theory is just some speculative, hypothetical idea within physics that's focused on in mathematical physics and theoretical physics, where you can look at equations and you can go, well, if the universe is this type of a universe, then maybe these things would happen. That's not about your everyday life. It's got nothing, dark matter has nothing to do with your everyday life. Antimatter production or where it all is in the universe has nothing, how the Big Bang happened. These are interesting questions that we should explore, because whenever we explore them, we have to develop tools and technology that improves our world and our universe. But we don't need those answers for our everyday lives. But that doesn't mean that physics on the whole has not been doing work and giving us answers in our everyday lives, because it has been for decades. Incremental advancements have been happening continuously in physics since modern physics was developed, which was 125 years ago, by the way. But the biggest one, the one that I can't believe I actually have to say out loud.
If you take the compute power of AI and point it at physics. Now, every bit of technology that we have comes from the physics department. And, what happens when you point AI at that?
AI exists because of modern physics. We don't have AI. AI in terms of artificial intelligence doesn't exist. We don't have intelligence. We have pattern recognition. We have really, really, really advanced models that are able to group together different terms and words and things that are recognizable and package them into a clean response, right? Now, in physics, machine learning and deep learning models have been under use and development for decades. CERN have always promoted the use of machine learning methods and deep learning algorithms in order to be able to look at how you can track particles' trajectories, especially in their detectors. These have been open projects that you as anyone could just go and do. I can't remember what it's called, Kaggle, is it? You could just go and sign up for one of these challenges. They've been doing this for a long, long, long time. What happened is all of this research, all of this scientific research got pulled out of science, repackaged by companies like OpenAI and Google and Anthropic, and turned into a product. And part of that product is a branding, and part of the branding is artificial intelligence. So now everyone in the world is obsessed with artificial intelligence and what it can do, but there's no intelligence involved. It is just advanced pattern matching, pattern recognition tools that are incredibly useful in certain contexts. They are only useful realistically when it comes to big data. Like, that's what they were originally developed for, how to handle big data. But it's not what you think it is, and it's not going to bring you what you think it's going to bring. It's a marketing tool, it is a product, and these people, the Peter Thiels of the world, are selling you a product. And they're using other rich people as their little parrots to sell you that product. Because all that matters to them is whether they can market it in a way so that their company stays at the top and they make the money. So it's not about like, oh, AI could advance physics. No. It's about, if we package this as, hey, look what it can do, and we get people to buy into it, then they will pay for our product. That is all that is happening here. And it's wild to me that we're not really seeing it properly. Anyway, that video really kind of set me off the rails. I was going to try and like be super chill on this. I was going to try to like, channel the Hannah Fry in me, but it didn't really work out. This is who I am. What can I say? Thanks for watching. Bye.